Assalamualaikum and hi. This is chapter 5 refrigeration cycle part 4. In this video I'm going to explain two subtopics: pressure enthalpy diagram and innovative vapor compression refrigeration system. Pressure enthalpy diagram. Pressure enthalpy diagram, pH diagram. So as you can see, this is the pH diagram, and the vertical axis, this one is the pressure axis also here, and the horizontal axis, which is this axis, is the enthalpy uh, axis. And we also, in this figure also, there is a number of line, and if you look closely, we have the saturated liquid line, saturated vapor line, enthalpy line, density, and temperature. Pressure enthalpy diagram, pH diagram. So this is the pH diagram, and from the previous slide I already showed that we have the saturated liquid line and also saturated vapor line. So the connecting line, if we connect this line, it become the saturation line. And from that also we have, as I show, we have a temperature. So this is the constant temperature line, the green color there is the constant temperature line, and this yellow color is the X value, which is the mixture ratio of the mixture, vapor and liquid. And we also have this red line, which is the entropy line, isentropic line, and we have this blue one, which is the density line. And from this PV diagram, as you can see, we have this subcool, which is the from the refrigeration cycle, vapor compression refrigeration cycle. And as already shown in the previous video, we have a constant pressure, which is the P is constant straight line. The straight line of process 2 to 3 and 4 to 1 is the constant pressure line, and the process of 1 to 2 is the constant isentropic process. So as you can see, process 1 to 2, it is along the isentropic line, and process 3 to 4, which has a value of H equal, and H3 and H4 is equal, it is in the straight line, and it is along the uh, pressure line, and it is at the same value of the enthalpy. So from this, we know that QH is equal to H2 minus H3, and H3 is equal to H4, and QL is equal to H1 minus H4, and work in is equal to H2 minus H1. So this is, again, this is the pH diagram, and let's say we have a temperature of 80 degrees Celsius and pressure at 2 megapascal. So, and we want to know the value of H and also S, which is the enthalpy and also entropy. So first we draw the constant temperature line, which is in the green color, and then we draw the 2 megapascal line there, and the crossing of it is here. And from this value, from this crossing line, we know that the enthalpy is around 440 and to 450 kilojoule per kg. We know the entropy, which is around 1.68 to 1.76 kilojoule per kg to Kelvin. We also know the density, which is around 90 to 120 kilojoule kg per meter cube. And let's say we have another point, which is the temperature is equal to 80 degrees Celsius and pressure is equal to at the saturated pressure, and that is the saturated pressure, which is along the saturated liquid line. So from this case, we did not know where is the position, exact position of the liquid or vapor mixture. So here we need another information, and in this case gave the entropy value, which is around 1.60, and from there we can draw a straight line from the entropy line, and we know the crossing line there, which is here, and from there we can know the value of H, rho, and also value of X. Value of X here is the ratio of the gas to the vapor to the liquid phase, so it is around 0.6 to 0.7. Innovative vapor compression refrigeration system. Innovative vapor compression refrigeration system. So in the refrigeration system, there is a ranges, which is for the high is around 8 degrees Celsius to 15 degrees Celsius, and for the medium one is negative 2 degrees Celsius to 4 degrees Celsius. And for the low one is around negative 28 degrees Celsius to 17 degrees Celsius. And based on the TS diagram, this is the domestic one, which is around negative 2 degrees Celsius to 4 degrees Celsius. And in the industrial application, normally it needs large pressure range and also large temperature range. And if you look at the TS diagram, the blue cycle, which is the industrial application, it has a large pressure range from 2 prime, 3 prime, and 4 prime to 1 prime, and also needs large temperature range. And for this case, it has poor performance of the reciprocating compressor, which is from the compression process. And the solution, which is to overcome this problem, we use a refrigeration process in stages with 2 or more refrigeration cycle in series, and it is being called as cascade refrigeration system. And for the 2 stages, as you can see, this is the 2 stages, and from this you can see we have B refrigeration cycle and also A refrigeration cycle. And the characteristic here, as you can see here, QH of the B cycle becoming the QL of the A cycle. And from the TS diagram here, you can see that from this case we can decrease in compressor work this much, and also we also can increase in the refrigeration capacity by doing this way instead of one big cycle, as you can see in this TS diagram. And from the analysis, we can know that the ratio of mass flow rate M A times in the bracket H5 minus H8 is equal to MB in the bracket times H2 minus H3. And the ratio of mass flow rate in A, cycle A, by cycle B is equal to in the bracket H2 minus H3 divided by in the bracket H5 minus H8. And the coefficient of power from the refrigeration of the cascade is equal to QL divided by work net in, and it is equal to M dot B times in the bracket H1 minus H4 divided by M dot A in the bracket times H6 minus H5 plus M dot B times in the bracket H2 minus H1. Innovative vapor compression refrigeration system. So this is the coefficient of power for refrigerant. It is equal to QL divided by work net in. And as you can see, this is the TS diagram of one stage, and this is the TS diagram of the 2 stage, and this is the 3 stage. As you can see, the number of stages increase, it will decrease the work input to the system, and also increase the QL, which is the heat absorbed from the refrigerated space, and also decrease the heat release to the warm space. And by doing all this, it will increase the coefficient of power, overall coefficient of power of the system. As a revision, you can try to do all these questions from Chengal books. This is the end of part 4 for chapter 5, and it is the end of chapter 5. Thank you, and hopefully you enjoy my video.